Hello everyone, welcome back. We're doing math videos today. Thank you, Shayana. Keep saying it wrong. Shayana, for helping me do these videos. Again, last couple weeks we've been doing square root functions, and we're going to be graphing them. So what we're going to do today is go over what we did, so you guys can have this for the test that's going to be on May 17th. And we're going to be doing this kind of stuff on the test, and also the function notation that we have a couple videos on. So listen up, try to get as much information as you can. Also make sure that you have your information from your notebook, okay? If you haven't done that, or haven't got all the information that you need for your notebook, please come see me during cruise so you can get that information, and so you can have a good notebook when you go take the test, because again, the test is going to help you with the notebooks, okay? All right, so what we're going to do today for square root function is we're going to talk about what the square root function meanings are, and then we're going to actually do a value, and then we're going to put it in a table, and we're going to talk about what the general rule is so you guys can get an understanding how to graph this stuff. Okay? So, number one, square root function. Alright? So a square root function has the same similarities as a parabola. Okay? And the same basically variables. Okay? So we want to just go over to make sure that you understand what happens with each variable as it moves. Okay? So, the equation is f of x equals a times the square root of x minus h plus k, okay? That seems very crazy, but it really is not, right? You just got to know what happens in each situation. So, I'm going to talk about the a value first, okay? This a value has some significant meaning, okay, when you talk about graphing this equation, all right? So, there's a parent function that we've already talked about before, where is a square root of x. That's the parent function. So basically what we're going to be doing is we're going to take this parent function and turn it into this and see what happens to the graph when this information is added onto it. Okay? So when the a value, what that does, if a is greater than 1, okay, if a is greater than 1, one thing happens. Okay? If a is greater than 1, then the graph is going to vertically increase. Okay, it's going to vertically increase or compress. Okay, that's number one. Vertically compress. I'll say larger. You get larger. Vertically get larger. Okay. Now, if a is between 1 and 0, it's going to vertically shrink. Okay, we've already established that before. So if the a value is between 1 and 0, it's going to vertically shrink. So it means it's going to depress into something smaller. Okay, and the last thing is if a is less than 1. So if a is less than, sorry, I did it the wrong way. Is less than 1. It's going to flip or reflect across an axis. Okay? So again, the a value makes those things happen. Vertically get larger, expand, or it's going to vertically shrink to get smaller, or it's going to reflect. It's going to flip over, and it's going to be opposite on the bottom side, like a mirror image. Okay? The most important ones that we need to know, because again, if we have these values, we can actually graph and figure out exactly what they are. Okay? But these values are the most important. Okay? These are very important. These are the points that give you the vertex of the square root function. Okay, you need to know the vertex. That's the starting point of the function, how the function looks. Okay, so what we say this is h. H is always going to be inside the square root. So it's going to say x minus h, x plus h, or whatever. Okay, the thing that you need to know about it is the value of the x vertex point is going to be the opposite of the h value. So if the h value is x minus 2, the actual value itself is going to be plus 2. Okay? So the reason why that is because if you zero that out or make x minus 2 equal to 0, if you solve for x, you're going to get positive 2. So that's why you do that. All right? So it's going to be opposite of h. Okay? So the opposite of h is basically the x value of the vertex point. Okay? The x value of the vertex point is the opposite of h. Now the one on the outside right here is the k value. So that's going to not be the opposite, that's just going to be a regular value. So anytime you might have x minus 2 plus 5, okay? So that 5 point is the k. That's going to tell us, okay, the y value of the vertex point, okay? Right. So again, whenever you want to find exactly where the square root function starts, look at this value inside here, and also look at the value outside here, and that's going to tell you exactly where the vertex point is. Now, if there's no value inside, just next, that means the h value is going to be automatically 0. If there's no value on the outside, it's also going to be 0 as well. Now, the other thing that the h, opposite of h, and the x tell you, okay, it tells you, let me actually, I forgot to erase this here, hold on a second, okay? It also tells you, all right, exactly how the line shifts, okay? So the h, which is right here, okay, and the k right here, okay, the h is going to tell us exactly if the line is going to shift right or left on the x-axis. So if it's at this point right here, if we change the h value, it could go left or it could go right this way. All right. So that's going to also help us. So the h is going to give us the shift, the translation. If you know what translation is, this means it's shifting right or left. Translation of right or left. Okay? Now that's opposite. Same thing as it here. If it's minus 8, minus 2, it's going to go to the right. Okay? Because we want the opposite value of x. It's going to go to the right. If it's opposite, it's going to go the opposite way, which is left as well, if it's plus 2. So we'll talk about that later on. All right? Now, the last portion is the y value of the vertex point. That's going to show the up and down shift of the graph. So that's going to translate the line up or down. Okay? So that means on the y-axis, so if the point is right here on the y-axis, it's going to go down. If the k is negative, it's going to go down this way. If it's positive, it's going to go up. Okay, from the parent function. So you need to know that. Okay, so right or left, up or down, and then shrink, smaller, reflect. Okay, so that's what you have. All right. So again, we have these in our notes, but if you just want to make sure that you take them down so you prepare for the test, at least you'll know exactly what happened to the graph when we do make some changes to it. So remember that probably be on something that we'll have on the test. Okay, so let's look at some values here and see how this works. All right, so I have two different equations, two examples I did. I have 2 times the square root of x plus 1, and I have negative 2 times the square root of x plus 1. Now, I did this on purpose, okay? And the reason why I did this is because the a values are different. So based on the information I have here, okay, see it said if a is greater than 1, that the graph is going to vertically enlarge this way. So it's going to be bigger. Now, since the other one has if a is less than 1, less than 1, which is true, that's 0, my fault, less than 0, then it's going to reflect, so then it's going to flip. So you should have basically the same vertex point in both of them, but the one graph is going to be larger like this, and the other graph is going to flip and be the opposite way. So you should have like a C. You should have a C on it. Okay? So let's prove and see how it looks. All right. So the first things first, when you're doing this, okay, you have to find the vertex point. So we said that the opposite of h is going to give us our x value. So if you look at this right here, you have x plus 1. So the opposite of the h, which is plus 1, is negative 1. So we would go one space over on negative 1, right here. Okay? Then, unfortunately, there is no k value. There's no k in both of these. So basically, that means is that the y value is going to be 0. So it's going to be right on this point, right here. So that's going to be our vertex point on both of them. All right? So, knowing that, we can work at the table so we can show you the general rule and how that works. Let me erase this little parent function here. Okay, so the parent function is inside the table here. So we got to think about, this is how I talked about in class. Think about it in terms of what x values can I use here that are perfect squares, that are close to 0, that will give me whole numbers if I square root of them. Okay? So we talked about those 3 values that you want to use. You want to use 0, 1, and 4. Okay? 0 squared is what? 0. I'm going to put this right up here so you can see what the functions are. Okay? Which is 0. All right? Then, now, what is the square root of 1? It's actually 1. Okay? Now, what's the square root of 4? 2. All right? So now we have a small little table here of the parent function. Now we can use that information here to actually be able to make a graph using a general rule. Okay? The only thing we're going to add in is the a value. So we're going to put the a value is going to be times. So every time we're going to put a 2 and a 2 and a 2 here. We're going to find out what that is. Okay? So again, I know this is not similar to what this equation is, but we can use a general rule to help us solve this. Now, if we know the parent function, okay, the parent function of the square root of x, this right here is going to be the vertex, 0, 0. That's the first point to point. So we don't really need that for our graphing portion. Okay, so I'm going to X that off. Okay? So, because we already established what the vertex was. It's over 1 to the left, and it's 0 because k is 0, so that's our first point. So, if we think about it, okay, if we move one space over to the right, okay, we move one space over to the right, back to our middle, okay, and then if we move one space up, that's going to give us our next point on our graph. Okay? The only difference is we have to make sure we account for this value of a. Okay? Because again, we said anything greater than 1 is going to make vertically larger, bigger. So to do that is we're going to take this value of the square root of x, which is 1, and we're going to multiply it by 2. So 1 times 2 is 2. And we're going to do the same thing for this one. 2 times 2 is 4. Okay? So now I'm going to circle the values that we're going to use to make our rest of our graph. Okay? So, we're going to start at this vertex point. We're going to go over 1 to the right. Okay? And then we're going to go up. Because this is the y value. We're going to go up 2 points. 1, 2. Right? And we'll make a point right here. Okay? Now, we're going to go over 4 spots. We're going to go back to the vertex. We're going to go over 4 spots. 1, 2, 3, 4. So we're going to go 1, 2, 2, 3, 4. So this is the 4th spot right here. And then we're going to go up 4 spots right here. So we're right here, 1, 2, 3, 4. So now we're going to make our square root function graph. Works just like that. All right? So again, let me say it again. We start our vertex point. We know we have a value of 2 in front, so we're going to multiply everything in the y's by 2. So we're going to go over 1 to the right, and then we're going to go up 2. Over 1, up 2. And then we're going to go over 4, up 4, right here as well. So that's how our graph is going to look. Okay? Very easy. Now, if we do a parent function of this, and we just went over 1, up 1, as you can see, just going to go over 1, up 1, over 1, up 2, this graph is going to be a little bit smaller than this bigger graph here. But I can't, again, we'll be here all week trying to tell you all that kind of stuff. All right? But I wanted to get an understanding of that. Now, we're going to use the same values, the same vertex point to actually do this one. Only thing that's different is now I'm going to change this from positive 2 to negative 2 for the a value. So I'm going to turn this around and I'm going to go negative 2. Negative 2, negative 2. Okay? So now, remember what we said. This is the vertex point. We don't need this one. We're going to cross that out. Okay, the one we need is now we got 1 times 2, which is negative 2. Now we have 2 times negative 2, which is negative 4. Right there. So, now our general rule change. Our general rules are still the same. The only difference is now we have to change the graph. So now we start at our vertex point, like we did before. We're going to go over 1. And then now we're going to go down 2. 1, 2. So we're right here. Make the best I can. Okay, the next one, we're going to go over 4. 1, 2. Sorry, 1, 2, 3. Actually, 4 right here, right? Same place we go 4. Now we go 2, 3, 4. Down. Okay, so our graph goes just like this. Okay, so like I said, we have 2 different functions. We have y equals 2 times x plus 1 plus k, which would give us the value going this way. Now if we add a negative, we're going to go this way. And like I said, we're going to make a c out of the whole thing. Okay, so there's 2 different functions, the same exact things. They just reflect on each other. So this one's on one side, this one flips it, and goes on the other side. Now, the question is, another question is, what is the domain and range? Okay, so let me do the domain and range for the first one, right here. Okay, domain is all the x values. Every x value that will be on this line. Okay, now where does it, basically what it's saying is, where does this end, where does it stop? So all the values have an answer to them. Okay, so if we did anything over here, okay, because the line is going this way, anything over here, then the if we plug them into the equation, we're going to get an undefined term. We don't want that. We want to get terms that are going to give us values of y. So, if you look at it, and we make an imaginary line right at this point right here, all the way down, okay, and anything across, that means that anything that's negative 1 and over going this way, greater than negative 1, is going to give us a value. So that would mean our domain is x is greater than or equal to negative 1. Okay? Because anything over here is going to give us a value. Anything over here is not going to give us a value. All right? Now, for the top one, we're only talking about the top portion here. Okay? Now the range. Okay? Like we said, if we think about it, and I take this out. Let's see. You can really see. Okay? Now, if we take this out, and we talked about the range. The range is right here. It stops right at the 0 point, and it goes up. So as you can see, the graph is going up this way, and it kind of bends out, but it's going to continue to go up as far as we go. Any value that we put in, we're going to get a number, so we're going to plot the point out of this graph. So therefore, we can say the range is anything on the y value is greater than or equal to 0. Anything lower than 0 is not going to give us an undefined point. Okay, so that's what we want to do. We want to be able to find the points that are going to give us values. Okay, anything over here undefined, anything under here is undefined as well for the y value. Okay, again, not easy to do. A lot of steps, a lot of things to do. You're going to have to watch this over a couple times. You're going to have to practice. That's why we have homework and things like that. So make sure that you're taking the practice so you can do well in this test. If you have any questions, please let me know. All right. Now I'm going to switch it, and now I'm going to do the domain and range for the other side as well. So I'm going to take this one out, take this crazy one out, and now I'm going to do 1, 2, 3, 4, 4. 1, 2. So now I'm going to make another graph this way. Okay. So now we did this one. Now we're going to make the domain and range for this one. So the same thing will apply for the domain. Okay, it stops right at this line. Okay, all these terms are undefined. If I put them in, if I put negative 2 in, I'm going to add an undefined term. So anything over here is going to give us a value. So that would make it be x is greater than or equal to negative 1. Now the other portion is the range. Okay, before the range was up here. So anything over 0 is going to give us a value of x. So we went this way. But unfortunately, now we have it going downwards. So again, so now it's going to go this way, but it's going to go downwards. So we have to flip the sign. So it would be y is less than or equal to 0. Okay? So anything under 0 is going to give us a positive, is going to give us a value for the domain. So that's what you have to understand. When it reflects, the range will change. The domain will stay the same, but the range will change and the sign will have to flip. Okay? That's also very important that you understand. All right. So, again, a lot of information here. You're going to have to watch this a couple times. Do the best you can on it. We're going to test on the things of God, of basically trying to draw this graph, trying to make the table, okay? I'm not going to test you on knowing this stuff, but you should know it, okay? But you're going to have to be able to make the table and understand what the information and what the domain and range is and know the rule. If you can do that, you should be able to get most of this information in. If you have any questions, please let me know, and I will help you the best I can. We're here to try to make you successful. We're not against you. I'm not on the other team. I'm on your team, okay? Make sure that you're working hard and getting through this. Thank you. That was long.